Hello everyone. In this lesson, I will solve the ministerial question of the topic of domain and range. Question number 1, find domain of f where f of x equal square root x plus 1. To find the domain of the square root, I'll set the term under square root greater than or equal 0 and solve this equation. Then x greater than or equal -1, then the domain is -1 to positive infinity. Choice number A. Question number 2, find the range of the function f of x where f of x equal square root x plus 1. The range of the square root, since it is preceded by positive, it is 0 to positive infinity. 0 to positive infinity. Choice number C. Find domain of f where f of x equal -1 over 2x plus 10. Since it is fractional function, then domain should not be 0. Then I'll remove the value, make the domain, the denominator 0. I'll set 2x plus 1 equals 0 and solve to find the value of x. Then x equals -10 over 5, -5. R minus -5, because -5 make the denominator 0. Find range of f where f of x equal square root 9 minus x square. If under square root I have a constant minus x square, then the graph of this function is half circle with domain from -3 to 3 and range from 0 to 3. Then choice number C is the right choice. Number 5, find the domain of the function 7 over 2x minus 10. Since it is fractional function, then I'll set 2x minus 10 equal 0, then 2x equal 10, then x equal 10 over 2, 5. 5 make the denominator 0, then I remove it from all real number, then R except 5 is the right choice. Question number 6, find range of the function f where f of x equals 7 over 2x minus 10. To find the range of this function, I set y equals 7 over 2x minus 10 and solve for x. Then 7 equal to y times 2x minus 10. Then 7 equal 2xy minus 10y. Then 2xy equal 7 plus 10y. Then 2x or x equal to 7 plus 10y over 2y. Then since y it is in the denominator, and when y equals 0, x will be undefined, then I remove 0 from the real number to find the range. Then the right choice is R except 0. Find the range of the function -3 over x plus 1. It is the same of the previous question. Set y equal -3 over x plus 1, then -3 equal yx plus y, then yx equal -3 y, then x equal -3 minus y over y. And the value when y equals 0, make x undefined, then I remove it from the range. Then r except 0 is the right choice. Question number 8. Find the domain of the function f of x where f of x equal 4 minus x squared under square root, or square root 4 minus x squared. A constant minus x squared, then the graph of this function is half circle from -2 to 2 the domain, and from 0 to 2 the range. I want the domain, then the domain is choice number C, from negative closed interval from -2 to 2. Question number 9. Find the domain of the function f of x equal square root x minus 4. Set x minus 4 greater than or equal 0, then x greater than equal 4, then the domain is 4 to positive infinity. 4 to positive infinity is choice number D. Find the range of the range of the function is negative infinity to -2. Which function of this 4 function has range equal to negative infinity to -2? The first function, the range of the first function is -2 to positive infinity, because the domain of the square root here is 0 to positive infinity. Then the behavior of this function when x equals 0, f of x equal -2. When x equal positive infinity square root infinity minus 2, it is infinity. Then the range is -2 to positive infinity. It is not this function. For the second function, you know the range of square root preceded by positive is 0 to positive infinity. So this function is also wrong. The domain of square root is 0 to positive infinity, as you know. Then, if I want to study the behavior of this function, when x equals 0, square root 0, 0, minus 2 is -2. When x equal infinity, square root infinity, infinity, times minus negative infinity, -2 is negative infinity, then the range is from negative infinity to -2. Then the right choice is number C. For this function, as you know, the range of this function without negative is 0 to infinity. Since it's preceded by negative, then I have reflection by x-axis, and the range will change from negative infinity to 0. So it is wrong. The right choice is C. Find the domain of the function f of x equal to ln x minus 2. Since the ln defined only for positive number, then I set x, let me solve it here, x minus 2 greater than 0, then x greater than 2, then the domain is 2 to infinity to positive infinity, open bracket from side 2, choice number C. Number 13, find domain of the function square root x plus square root 1 minus x. Since I have two square roots, I find separately the domain of each one and find the intersection interval of both roots. The first one, the domain of the first one is 0 to positive infinity. The domain of the second one, I set 1 minus x greater than or equal 0, then 1 greater than or equal x, or x less than or equal 1, then the domain here is negative infinity to 1, close interval from 1 and open from negative infinity. The intersection of these two intervals, 0 to infinity, with negative infinity, this is 0, this is 1, negative infinity to 1, the intersection interval is 0 to 1, closed interval from 0, from the side of 0, and closed interval from the side of 1. Then choice A is the right choice. Question number 14. Find the range of the function, piecewise function, f of x equal 2 minus x less than 2, negative square root x minus 2 when x greater than or equal to 2. X less than 2, it means the range of this segment is, the domain of this segment is negative infinity to 2. And x greater than 2, it means the domain is 2 to infinity. Let us study the behavior of both segments. When x equals negative infinity, 2 minus infinity, it is infinity. When x equals 2, 2 minus 2, 0. Then 0 to positive infinity is the range of the first segment open from the side of 2, since 2 is not in the domain. For the second segment, let me study the behavior. When x equal to 2 minus 2, 0, 0 times negative is negative 0. Then from 0 to infinity, minus to infinity, square root infinity times negative infinity. Then I have negative infinity to 0, close interval from side of 0. The union of these two intervals from 0 to positive infinity, from negative infinity to 0, 0 is within the second interval, then the answer is all real number. Question number 5. Find the domain of the function f of x equals square root x power 2 minus 4x plus 3. I'll analyze, or without square root, I'll analyze the term under square root by experiment equal to x minus 3, x minus 1, then x equal to 1 and x equal to 3. Then the domain of this function is negative infinity to minimum value of x, 1, union maximum value of x, 3, to positive infinity. Then choice number D is the right choice. Question number 16. Find the range of the function 7 over 2x minus 4. To find the range, set y equal to 7 over 2x minus 4 and solve for x. Then 7 equal to 2xy minus 4y. Then 2xy equal 4y plus 7. Then x equal to 4y plus 7 over 2y. Since y is in the denominator, should not be 0, because 0 make x undefined, then the range are except 0. Choice A. Find the domain of the function square root 1 plus x, set 1 plus x greater than or equal 0, then x greater than or equal negative 1, then the domain is negative 1 to positive infinity. Negative 1 to positive infinity is choice A. Find the range of the function. This question is the same of 16. It is R except 0, the same steps in 16. Number 19. Connect each function with its domain. This is the function. Let me find the domain of this for function, and then I'll see the right choice. Fraction function, rational function, domain should not be 0. X power 2 plus 1, never. There is no real number make it undefined, since x power 2 plus 1 equals 0, then x power 2 equal negative 1, then x equal negative positive square root negative 1, not a real number. Then the domain of this function is all real number. Len x plus 1, x plus 1 should be greater than 0, since then defined only for positive number. Then x greater than negative 1, the domain is negative 1 to positive infinity, open bracket. Negative 1 to positive infinity is choice, the last choice. Square root 1 minus x power 2, a constant minus x power 2, then the range or the domain of this function is negative 1 to 1. Because the graph of this function is half circle from negative 1 to 1, and the range of it is 0 to 1. Then the domain is negative 1 to 1. The last function, 3 over x minus 1, absolute value x minus 1. X minus 1 should never be 0. Then the value make it 0 is 1. Then I remove 1 from real number r except 1. The right, this is the domain of this function. As you see, choice number D is the right choice. Question number 20. Find the domain of the function square root 36 minus x power 2, a constant minus x power 2. Then the graph of this function is half circle from negative 6 to 6, the domain, and the range from 0 to 6. We want the domain, then choice number C. Find the range of the function for 2 square root 4 minus x. The range of this function is 0 to positive infinity. Choice number D, since the root preceded by positive. 22. Find the range of the function 49 minus x squared, a constant minus x squared. Then the graph is from negative 7 to 7, and the range from 0 to 7. Choice number T. Find the domain of the function 4x over square root 4x plus 12. Since the numerator is 4x, then the domain of the numerator is r. Let me find the domain of the denominator. 4x plus 12, it is under square root, should be greater than or equal 0. Since it is in the denominator, the term should not be 0. I remove 0 and solve to find x. Then 4x greater than negative 12, then x greater than negative 12 over 4 equal negative 3. X greater than negative 3 is negative 3, open interval to positive infinity. Intersection with r will be negative 3 to positive infinity. Negative 3 to positive infinity is choice B. 24. Find domain of the function x over 12 square root 12 minus 3x is the same as the previous one. 12, I'll set 12 minus 3x greater than 0, not greater than or equal, since it is in the denominator. Then 12 greater than 3x, then 4 greater than x or x less than 4, then the domain is negative infinity to 4. Open bracket from 4, open bracket from negative infinity. Negative infinity to 4 is choice number A. Of course, negative infinity to 4, I take it intersection with the denominator, with the domain of the numerator r. The answer, it will be negative infinity to 4. Find the domain of the function x over x power 2 plus 1. Since x power 2 plus 1, there is no value, make it 0, because x power 2 equal negative 1 equal to x, give me x equal to negative positive square root negative 1, not a real number, then the domain is all real number. There is no value, there is no real value, make the denominator 0. Find the range of the function negative 3 over x plus 1. To find the range, set y equal to negative 3 over x plus 1, solve for x, negative 3 equal to yx plus y, then yxy equal to negative 3 negative y, then x equal to negative 3 negative y over y. Since y is in the denominator, should not be 0, because make the x undefined, then the right choice is all real number except 0. Find the domain of the function f of x equal ln 2x plus 6. Ln defined only for positive numbers, then x plus 6 greater than, should be greater than 0. 2x greater than negative 6, x greater than negative 3. It means negative 3 to positive infinity, open bracket. Negative 3 to positive infinity, open bracket, is choice B. Question number 30. Find the domain of the function f of x equal ln 10x minus 10 minus 2x. Since 10 defined only for positive number, then 10 minus 2x should be greater than 0. Then 10 greater than 2x, or x less than 5. X less than 5, it means negative infinity to 5, open interval. Negative infinity to 5 is choice A. Find the domain of the function x power 2 minus 9. X power 2 minus a constant, it is negative infinity. I'll analyze this the term under square root by difference of 2 square to find the minimum and value and the maximum value of x. X equal 3 and x equal negative 3. Then the domain is negative infinity to negative 3, union 3 to positive infinity. It is choice number A. Negative 3, negative infinity to negative 3, union 3 to positive infinity. Number 38. Find the domain of the function 4 over square root x minus 5. Since the square root is in the denominator, then I'll set x minus 5 greater than 0, not greater than or equal, because the denominator should not be 0. Then x greater than 5, 5 to positive infinity is the domain of this function. Open interval 5 to negative 5 to positive infinity. Choice D. Number 40. The domain of which function is negative infinity to 4? the domain of this function, let me find the domain of this 4 function. 4 plus x should be greater than 0, or x greater than -4, then the domain is -4 to positive infinity. So it is wrong choice. The domain of this function, 4 minus x greater than or equal 0, 4 greater than or equal x less than or equal 4. It means 4 negative infinity to 4, close, open. So also this one is wrong. Then 4 minus x should be greater than 0, then 4 greater than x less than 4. It means negative infinity to 4 open interval. This is the right choice. For number D, the domain is all real number since the term inside the absolute value is linear function. Find domain and range of the function 1 over 2x minus 3. As you see, the domain is all real number except 3, since the 3 make the denominator 0. So all choices are true. For the range, we solve like this question many times, is r except 0 or y when y not equal to 0, then choice number B. The last question in this lesson, find the range of the function f of x equal 1 minus x power 2 when x less than 1 piecewise function, and 3 minus 4x when x greater than or equal 1. 1 minus x power 2 is quadratic function. Its graph is a parabola open to the down from negative infinity to 1. The range of this function is from negative infinity to 1. For the second segment, 3 minus 4x when x greater than or equal 1. Let me study the behavior of this function. The domain is 1 to positive infinity. When x equal 1, 3 minus 4 times 1 is -1. Then -1. When x equal infinity, then 3 minus 4 times infinity, 3 minus infinity, negative infinity, then the range will be negative infinity to -1 with -1, open bracket, from the side of negative infinity. The union of these two intervals, let me do it here on the number line, from negative infinity, this is 0, this is 1, negative infinity to 1 for the first one, and negative infinity to -1 for the second one. The union is negative infinity to 1, choice D. See you next lesson.